All right, here we go. We're learning about functions today. Review class number 3, all about functions. So the stuff that I wanted to cover today is, first off, how do you define a function? And I'll say specifically, how do you define a custom function, your very own function that you want to create, and how that's different from defining something like the setup function or the draw function. All right, we're going to talk about the difference between arguments and parameters. That's something that's hard to wrap your head around, especially if you are new to programming, so I will try to be as specific as possible with my language. To be honest, people interchange those quite a bit, but I'm going to be really, really careful not to so you're clear as what is what. And we're also going to be finding out about push and pop matrix and translation, translate and rotate. I'll put it like that. And we'll use these in conjunction with functions as well. They are functions, and they'll help our functions kind of look like the existing functions we have. Ultimately, our goal today will be creating our own functions to draw somewhat complex shapes. We won't get too crazy because we don't want to spend all day just drawing stuff. Well, maybe we do, but we're not going to because we got stuff to do. So we're going to be making some complex functions. By the end of the class, you'll have made 3, 2 of which we'll do together, and 1 of which you will do on your own in the review time. So we'll make some custom functions, and we're also going to remind ourselves about 2 important concepts. So one of them is dry code, which we talked about last year. Don't repeat yourself is what dry stands for. And also code, I don't know if this will fit, reusability, just about fit. Code reusability, which isn't something we talked about too much last year, but is an important concept. So we will touch on all these things, as well as make some fun functions. Okay, so as we get started, we're going to start with our setup here, and we'll just choose a size. I think I'll just go with good old 800 by 600. This was the standard resolution for monitors when I was doing my computer science degree, which will tell you how long ago that was. And let's go ahead and make ourselves a function. I wish there was a function that would draw like a house. Like I just want to be able to say like house and be like, I want my house at like maybe 200, 200. Go. And it would just like make a house. We got a line function and a rect function and a triangle function and an ellipse function. Why don't we have a house function? Well, at some point it's ridiculous. So you can't have functions for everything. But maybe you do need a house function. Maybe you're making a city simulator and you want to draw houses over and over again. So this is the kind of thing we're going to do. Right now this doesn't work. Right? It underlines it in red. I don't know if you can see it, but it says the function house int does not exist. So that's what we're going to do. We're going to go create a custom function that we can reuse over and over again and make customizable by giving it different arguments so that we can make a whole bunch of houses, just like we can make ellipses or circles or rectangles or anything. So to do that, we need to make a new function. We already have setup and we have draw. Those are also function definitions, by the way. But notice how they turn green? That means they're like special. They're plugged into processing in some special way. We talked about these ones last class. Setup always happens at the very start, right? Draw happens in this loop, and there's a frame rate sort of calculation going on. So if you make your own function, you just go beyond the last brace. Sounds like an epic place to go. Beyond the last brace lies the custom functions. So there it is. We're going to go down here, and anywhere after that last brace, be careful not to put it inside or you'll break stuff. You can start defining your own functions. So you just start with void. And right now we're going to use void for all functions, but later on we'll see that you don't have to. There's other choices, but for now it's basically void. And I can say house. You put the space for these 2 parentheses to go together, and then you put in your braces. So it looks kind of like draw. You'll notice that this is still an error, so something's not working here. And I'm just going to simplify it for now. I want to get rid of this 200, 200. That's great. I eventually want to be able to say, hey, house, you belong here. But for now, let's keep it simple. Let's get rid of that. And we'll just say this function draws just the house, just one house. So let's go draw a house. I'm going to draw a rectangle and a triangle on top of that rectangle. If you would like to right now draw a lovely house, please by all means do so. But I'm going to custom build this house right now. I think I'm going to do, I guess I'll do the rect first. I don't know, I'll stick it at maybe 400, 300, and I'll make it 100 by 100. Ooh, there's a good skill testing question. What would be the triangle that would go on top of that house? So let's run it. Notice that it draws the house. So I'll bring this up. I did this last class. You can see I had a lovely diagram here. Let's make that triangle. You guys can help me. So I want to make a triangle that's like roughly like this point, and this point. It'll kind of connect together to make the roof of the house. So I know that this point here is apparently 400, 300. All right, so what is this point going to be and this point going to be? Yeah, William. Oh, and by the way, this is 100 wide. That's going to be important to know. 100 tall. All right.
I think 500, 300.
So this one here, yeah, so that's be 500, 300. I agree with that.
And the big one, 450, and depending how tall you
Yeah, and then we'll say that's like maybe 50 tall or something. So it'll be minus 50. Ooh, because we're going up. So maybe 250. Yeah, so those are the coordinates for those points. Yeah, look good. So if you ever are trying to draw something and you need to like just map it out, feel free to grab paper. There's always some scrap paper that's on this table and some pens and stuff. So if you're ever trying to like source out where that's going to be, that's good. Okay, so let's close that and I'll type those in. Great, so we'll make a triangle. Okay, cool. It's going to be, what do we decide? So one's going to be 400, 300. And then the middle one was 450, 250. And then the final one was 500, 300. Okay. Okay, now I'm going to run it and just see if I got a triangle on top of my house. Yeah, there it is. Awesome. Okay, there's a house. Woohoo. Now, if I keep it this way, I'm in a bit of trouble because that house can never really change where its location is, right? I can't move those numbers. 400 is always where 400 is, right? I can't really get things to move around. So there's two ways to solve this problem, and we'll start off with making the coordinates, instead of making the coordinates hard numbers, we'll make them relative to some sort of variable. So instead of having a house, like if I draw two houses, they're going to be overlapping each other. This is the problem, right? If I say house and then house, I still only have one house because they're just on top of each other. I want to be able to say, draw this house at 200, 200. And then I want this house at 400, 400. Oh, so hard. It doesn't do it because it's always hard-coded. So let's go and solve that problem. So first of all, what is the name of these numbers here that are the input part of the function? That's what they mean, yeah. But what is the general term for whatever numbers I'm sending the function? Yeah. They are inputs, yep. But there's another term for it. It's synonymous with fighting. Usually verbally. Arguments. Yeah, you got it. Arguments. You got it. This is an argument. It's not that it's like, oh, I'm arguing with you. I guess you could think of it that way. I'm arguing that this house should be at 200, 200. Well, it always wins. It'll just obey. So, yeah, these are called arguments. So, right now, this doesn't work. It's highlighting as an error because if you want your function to take arguments, you have to create special variables called parameters that accept those arguments. that are in the right place to be like, oh, I'm going to take this argument and that's going to be my value. So where do parameters go? Parameters and arguments are sort of like two sides of the same coin. They go right here in my function definition. This is where I would put parameters. So parameters are just variables that give a name to what these arguments are. So for example, I could say int x, int y. This means that my house function accepts two arguments, and they're going to be accepted by this parameter. The first one's going to go into this parameter. The second one's going to go into this parameter. Parameter is just a fancy word for a variable. And they're put into specific places to allow functions to have arguments. Does it make sense between the difference between an argument and a parameter? An argument is a value. A parameter is a variable. Arguments are when you call the function. Here's where arguments are. Arguments are values you send to functions. I'll just put funct. And parameters are variables that store arguments. I'll just go to another line here. So in f of x notation, right? F of x, the x is the parameter. If you said f of 9, 9 would be the argument. If you said f of g of x would be the argument. Although x inside of g of x is also a parameter. So that gets a little confusing. But that's the difference. Any questions about that? The difference between arguments and parameters. I'm going to be using these words a lot today, so you might have multiple chances to ask me questions about that if that gets confusing. So let me know. So here's my arguments. That's where I want the house to go. Inside of the function, though, I'm pretty much ignoring them, right? Like if I run this, sure, I can say I want it at 200, 200, I want it at 400, 400. But those are just wishes right now. They don't actually do anything. My houses get drawn on top of each other. So you have to make those parameters meaningful by plugging in the variables into our drawing, our shape functions. So for example, for my rectangle, I could change the 400, 300 to have x and y instead. X, y. The triangle's a little bit trickier because like this corner is also x and y, right? They share the same corner. So we'll go x. Maybe I should go back to the drawing board actually. Let's go back here. Maybe I should run it first. I don't think I'll get it where I want it to be. Let's put a 400, 300. All right. Yeah, there we go. So no longer is this necessarily 400, 300. Let's talk about this as an abstract coordinate. Let's just call this, I'll erase all these things. Let's instead call this, I'll use maybe black. Let's call this x, comma, y now. So what will be the coordinates? This will be the coordinate of one of the triangle points. What will this coordinate be now? And what will this coordinate be? If that's x and y, what's that going to be? Let's start with this one here. This one's probably the easier of the two, but they're both about the same. Thanks, Willie. Yeah, we can say the x coordinate is going to be whatever this one is, plus 100. There we go, that's 100. And the y coordinate? Just y, you got it, thank you. Yeah, nice. How about this one here? Whoa, that was so synchronized. X plus 50, y minus 50, sure, or whatever number you prefer. The 50s and the 100s come from the dimensions of the house. So, that's fantastic. Okay, so let's go make that happen. I'm going to now change my house to now have those coordinates. So this one is still xy. This one was x plus 50, and this one was y minus 50. That was the peak of the roof. And this one was x plus 100, y. Okay, let's see. Do I now have two separate houses? Let's run it and find out. Yeah, look, now I have two houses. The reason why this works is because my house isn't just a hard-coded place on the screen for these shapes. This now becomes a formula for how to draw a house. Right? You see how that is? It's all abstract now. And it's based around these arguments. But of course, the arguments might change, right? I might make a third house. House, Hosu? No, house. There we go. 500, 100. These arguments can change. But inside of the function, we always just refer to these as whatever the names of the parameters are. In this case, x and y. So it doesn't matter what numbers we send it, we just plug those numbers into the formula. Same as like f of x or g of x in math class. So I think this will work if I run a second one. Great, we got three houses. It's going well. So just pause for a second and think about drawing these three houses. If we did it the old-fashioned way, where we said three rectangles and three triangles, then we would just kind of be repeating ourselves over and over again, right? If we want to reuse this shape, it's probably better for us to make a function. We're not getting a ton of value out of it because it's just two shapes, but it's still pretty good. And if we ever want to change all of our houses, then we just have to change it in one place, and all of our houses will change. So if I wanted to add a door onto my house, I could put a door right here, right there, and then all three houses would get doors. So we're magnifying our effort. We're working smarter, not harder, is another way to put it, right? Everybody wants to be lazier. I mean, last year we talked about it's a goal to be lazy. You have to be a little bit smarter to do it, but that's okay. That's what we're here for. We're here to get smarter. So functions are great for making sure that you don't repeat yourself. And that's good because then you can reuse that code over and over again. I can use this in another project really easily. I can bring this function over. How many people reuse their functions from project to project, right? Like how many times did you copy that button function or your whatever, right? It was so nice to reuse that code. In fact, by the end of the course, you might have been like, I don't even remember how I made a button. It's just this code that I bring over from project to project. But isn't that powerful? You're able to then concentrate on other things instead of coding that button every time. So it's a really powerful idea. And those are those concepts of code reusability. I mean, literally, you want to do this. I didn't tell you to copy the button function, and you did over and over again, right? And don't repeat yourself. Two powerful concepts that you'll see over and over again in computer science that will make our code better, more powerful, faster to write, and easier to find the mistakes in. So all good ideas. Okay, I'm going to add in a new set of parameters. I would like you to finish this off. I'm going to tell you what these parameters are. I'm going to get rid of one of the houses. I'm going to add in an RGB set of arguments. So if I wanted to have a red house, I want to do 255, 0, 0. So that house should turn out red. And if I wanted a blue house, I'd do 0, 0, 255. There's my blue house. So I expect this house drawn at these coordinates to be red and this house at these coordinates to be blue. How would you do that? And what steps would you need to do? Go ahead and try it out, folks. If you're not quite sure, think about the fact that this isn't working anymore. And if I add these in, what else do I have to add? And if you're still not sure, try to put that into a sentence of what you're not sure about. Just inside of your own head. You don't have to say it out loud. It'll help you to see what's going on. Lucas, thanks for your question. The overall idea? Oh, no worries. So we're making we're expanding our function to take in a red, green, blue arguments, and that's going to change the color of the houses. Let me just write that down to make sure it's clear. So we're adding. So now it's X, Y, R, G, and B. So I want it to take 5 arguments now. Yeah. Yes. Yes. Good question. So you're on the right track. You're like, oh, what do I need next? And you went to the right place. I can't remember how that worked last time, but you don't need to use strings or anything like that. We can just use numbers. Yep. Okay, we'll take a second to do that. You can check some water. All right, everybody. I'm gonna pause you there in case you didn't get it yet. I think this is a pretty big jump, especially for folks who haven't done much programming yet. This is a big leap. And it might be a big leap for those of you who have done some programming before. So I just want to remind you about the arguments and parameters. What's the difference between them, right? These are arguments. If you're giving arguments, there must be parameters that will be set up to accept those things. If I send 5 arguments, then my function better have 5 parameters. So I'm going to expand my list of parameters here. I'm going to include an int r, int g, and int b. Do they have to be called these these names? No. You can be called anything, but that makes sense. So I'm going to use those. If I run this, does that do anything? Not really. Like, those numbers are there, and we're passing them. The arguments are being caught by those parameters. It's just we're not doing anything with them. And actually, processing highlights them in yellow. Just to remind you, hey, look out, you forgot to use these things. You made them. So you probably meant to do something with them, but you didn't. So it's what's called a warning. So let's use them. How do I use them to fill my colors? Oops, did I just spoil the answer? I did, yes, it's fill. So we'll just stick the fill at the beginning. I can say R, G, and B. So now this is a recipe for building a house, right? I say what colors and what location, and I go from here. Run, go, let's see it. Yeah, I got a red and a blue house, and I can make a green house and stick it wherever I want to, or a fuchsia house, or whatever I want. So we're building our own custom functions. Isn't that great? We're expanding the processing language, right? Now processing knows what I mean by house. That's kind of cool. I see we're moving along at a pretty good pace. I got one more parameter I'd like to add in here. I'll say argument. What about if I wanted a size? Ooh, this is going to be a little tricky, but yeah, the same idea. So I'm going to say x, y, RGB, and let's put in I'll just put S for size. So this will be like how long the walls are. Right now, they're 100, right? I have it hard-coded as 100. Let's change it to make that something I can change. So I'll say 100 would produce the exact same house, but I can make maybe a smaller house or a bigger house. We're getting pretty long lists of arguments now. Let's say I make it 150. It would be like 50% bigger. I could put in 200 or 500 or 1,000, and it would grow the house. So what would you do? What would you need to change? First, the definition of the function, and then the actual recipe for drawing the function, drawing the house. This is getting really tricky now, folks. So take your time. I'll give you a minute. 3 or 4 minutes. Yeah, this stuff gets really tricky because it's abstract. You might remember back in like grade 8 maybe, or grade 7 when you started doing algebra, X was suddenly in your math for the first time. And it was like this kind of struggle to be like, ugh, and you've got that now. Like you're doing okay in algebra. You can solve for X these days. But when you first started, you remember that kind of uncertainty of like, oh, it feels weird when there's variables here. So that same kind of uncertainty is probably settling in your heart because this is a new context for that. So just a hint, like these numbers are going to change, but so are these numbers as well, right? And think about the relationship of these numbers to these numbers. And that'll probably get you along the way, or at least part of the way. All right. So let's say 1 more minute to work on that. If you got that, great. Fantastic. Congratulations. Okay, folks. I'm looking at the clock, and I think we should probably reveal the answer now. If you didn't get it, that's okay. Kind of think about where you are a little bit confused, and I'll show you what's the story here. So again, our last argument is representing our size. So I got to make sure I match it in the right order, right? If I put size at the beginning, that's going to mess everything up. Size is at the end, so I should put my size parameter at the end. The order should match up with the order of the arguments. And that's arbitrary. You could choose the order. If you wanted x to go at the end, you could do that. But you'd have to remember that's the order. So I'll put size at the end of the parameter list. Int s, I'll say, for size. So that's cool. I can say this is my s now, s. And if I run it, I'll get different size rectangles, but my roofs aren't changing size. So if I just put this back to 100 for a second, what's the relationship between this number and that number? It's half, yeah. It's half. And what's the relationship between this number and this number? It's the same. So we can kind of reverse engineer the pattern just by looking at the relationship between the numbers. So this is half because we are going halfway to make the peak, right? And we go halfway up because that's just what we decided was going to be. And I think that's great. This one is all the way over. It's a full S length over. So that's why we put in, if this was S, oh, no, there we go. That's going to be S. This is going to be S divided by 2. Yeah, and this can be S divided by 2. And yes, processing knows bed mass. So x plus S divided by 2, it'll do the division first, and then add it. Last but not least, that's just going to be S. And suddenly we have no numbers at all in this entire house. This is literally a formula for a house. It's a reusable formula, and we can plug in the numbers up here when we decide to build our house. Does it work? I don't know. Let's see. Those two examples work. Yeah, great. So functions are really valuable to save us effort. If you want to draw 100 houses, well, now you have a way to do that. You can make a loop and you can change the parameters and all sorts of things. So I think that's a pretty fantastic thing to do. Also, don't forget that these are just like rect now, or ellipse, or line. You can plug variables into these things. Right? I could plug a variable into here and make my house grow and shrink and whatever I want to do. I can plug it in here and make it travel across the screen. I could change the colors of the house with variables. All the things we could do with rectangles and ellipses, we could do with houses as well. In fact, you can make a neighborhood function that draws houses. Just like we have a house function that draws rectangles and triangles. So you could endlessly build upon this to make more and more structures. And that's kind of what we're going to be doing in programming. So there's our house function, and thanks for checking that out. We do have another option, though. This can be tricky. This sort of formulaic thinking is great when your shape is formulaic, but if you just want to draw a specific kind of shape, and maybe there's not really a formula for it. I don't know, I don't have a good example off the top of my head, but maybe like you're drawing a particular kind of face, like the Rage comic faces, like the LOL face, or like the whatever. Like maybe you don't actually have this nice formula for it. So there is another way to do this kind of thing by making a function, and you don't even have to put any variables inside of here. You can just change the coordinate system instead. So we're going to do the final part of our lesson now. We're going to be talking about push, pop, matrix, and translate and rotate. So I see, Sarah, we're probably going to run out of time, so check the video. I'll post that at the end of the day. Oh, is it tomorrow's class? Oh, I'm so glad you're going to be able to see this. I'm so glad. That's so fantastic. So we're all going to get to see this whole translate and rotate kind of concept. It's going to be great. So let's all make a spaceship, or like a rocket ship or something. I think that'll be a nice thing to draw in. I love spaceships personally. Growing up, I was a huge sci-fi nerd. I still am a huge sci-fi nerd. There's Star Trek posters at the back of the room and inside of the room and all sorts of stuff. So let's just go make some spaceships. And my goal for this one is not to make it quite so formulaic. I want to just draw a cool spaceship and use those coordinates just like they're all hard-coded, but then I'm going to move around where the origin is instead. And I'm going to also rotate the whole drawing surface. So to do this, I'm going to ask you to make a new function. It's going to be called spaceship or rocket ship. You can call it whatever you want. And it's going to take in an x and a y for now. And that's going to be great. If you are feeling a little low on your creativity and you're like, well, I don't know how to draw a spaceship, then you can take a look at mine. I don't care. But I'm going to go draw a really sweet spaceship, but I'm going to plan it out in another sketch. I'm going to open up another sketch right now. It's going to be a static sketch, so no void setup, no void draw. I'm just going to plan out its coordinates. So I'm going to do that right now. I'm going to go File, New. Here's a new sketch. I'm going to make it maybe 400 by 400, the size of the window. And then I'll just run this. So when I draw my spaceship, it's really important to make it centered around 0, 0. When I actually draw my coordinates, if you're using this technique, you want to center the drawing, whatever the center of rotation would be for your object, at 0, 0. That's going to be a little hard to draw, though, because mostly that's off screen. That's kind of annoying, right? So what we can do is we can actually shift where the origin is to the center of the screen for ourselves to draw this picture. Okay, so I'm going to do that right now. It's not hard to do. It's called translate, which is another word in math. You may have heard of translate when you're working with parabolas. Did anybody translate parabolas like 50 million times in grade 11? And if you haven't taken grade 11, you will translate math. You will translate parabolas 50 million times, as well as squish them and stretch them and turn them sometimes and all sorts of fun things. So translate just shifts the whole coordinate system around. So it takes two arguments, and they are going to be the new coordinate of 0, 0. So I want to put them in the center of the screen. 200, 200 is the center, right? If I run this, it's not particularly exciting. You won't see much happen. It's still just a nice little graphics window. So let me show you what has changed. If I say circle 0, 0, and maybe make it like 10 wide, that is now going to be drawn in the center of our screen. There it is. There's our 0, 0. And if I draw negative x coordinates, they'll be drawn over here. If I draw negative y coordinates, they'll be drawn up there. So now I can plan my drawing around this 0, 0. So I can see my spaceship and draw it and make things work a little bit easier for us. So that's what translate does. Translate moves the origin to a new place, which is kind of cool, I think. We'll see. See how that goes? Okay, so there's a circle. I'll leave that circle to be like a window. And why don't you go ahead and just draw your own cool spaceship? I don't mind if you want to just copy me as well. But if you'd like to draw a spaceship, use a few different shapes. I'm going to use some triangles. Just have at it. Just go have fun time drawing a spaceship. I'm going to go make mine have a triangle. Oh, yeah, John? You're good? Okay. You might screw up, as I did many times last class drawing my spaceship. I might have more luck this time. I got to think about this. And again, it doesn't really matter what it looks like. This is not a spaceship architecture class. It is not a drawing class. You can draw it however you like. Yes? Here? We just made the spaceship function. Oh, Command Y or Control Y, I think. If you go to the Edit menu, it tells you the redo. So you can see. Okay, I'm making my... Oh, look, I've made a spaceship over here. I'm not going to cheat. I'll make my own new original one. It's tempting, though. Let's see. Maybe... Notice how as I do it, I make a shape and then I run it. And I'm like, is that good? And you're like, yeah, that's what I wanted. But I will also make mistakes as I go. So I just run it and run it and run it. Every shape I add, I don't wait till I've drawn 10 shapes and I look at it and it turns out it's like a Picasso spaceship, and I'm like, I have no idea what's happened. So one shape at a time. I always run it until I get that shape in the right place. Just makes things easier, I think. And it's kind of hard. I'm not gonna lie. At the end of the day, anyways, to get the coordinates. So it's good mental exercise. But if you're feeling, tired, then I understand. Okay, I added in a little engine. Let's see if it works. Yeah, that's okay. I'll take it. I'll add in another engine. I think I just have to make these positive. Helps if you make a symmetrical design. Yeah, all right, I'll take it. That's pretty good. Okay, I got a spaceship. I'll give you guys a couple more minutes, and if you have a question, call me over, and I'll be happy to answer. That's my spaceship. If you are out of energy, then you're welcome to use it. Don't get too carried away with the spaceship boats. I know it can be fun to draw spaceships. I certainly enjoy spaceships. Okay, one more minute, folks, to finish up your spaceship. Whatever it looks like in 1 minute is what you're going to be using as you go forward. And again, it doesn't have to be anything in particular, so don't feel like gotta be triangles or anything. I don't care. That's kind of a Star Destroyer with like extra big engines on it or something. I guess if I put my big triangle on top, it would look a little more Star Destroyer-y. It would need that kind of big thing that is on the back there. And what it's called, like where the command center is and stuff. Okay, 10 seconds, folks, 10 seconds. I feel like we're on some kind of reality TV show where you're given like a random set of shapes and you have to build a spaceship. You give it a certain amount of time. Okay, time's up. If it was a reality TV show, then one of you would get cut. It'd be like, sorry, you have to go home. And then eventually there would be only one student left, and it would be like, you are Canada's greatest programmer, yay! There'd be like tears every episode. Wouldn't that be the worst way to learn? That'd be so stressful. Anyways, I'm sure I've had a nightmare along those lines. Okay, so we got a spaceship. You got a spaceship. We're all ready to go. Hey, can I just ask you to confirm that you, like, what is the reason why we translated to 200, 200? Yeah, we can see it because we want to draw it around 0, 0. And why do we want to draw it around 0, 0? That's probably like the missing thing. But William, you got it?
Because when you put this over there,
Yeah.
something needs to.
Yeah, there's a little missing kind of information there. So thanks, that's great. We kind of want the spaceship to act like ellipse, right? When you say x and y for an ellipse, you get the ellipse centered on the xy coordinate, right? We want our spaceship, when we say spaceship, xy, we want it to show up as the center of the spaceship at that xy. That's why we've drawn it centered that way. If we didn't draw it centered that way, it would act more like the rect function or something, and that could be a bit challenging for a spaceship. So that's the exact reason why we've done it. Thanks for puzzling that out with me. So I'm going to copy and paste this over to my spaceship function. Are you ready? Don't bring the size over. We're leaving that behind. We're going to do everything from translate down. So I'm going to take the translate, all this kind of stuff. I'm going to copy it over. Control C, by the way. Anybody who's right-clicking and going copying, no. Learn those shortcuts. You can do it. It's okay. I'm just joking. But it is good to learn the shortcuts. Command V or Control V to paste. Oh, here's another great shortcut. When you paste it, the indenting gets kind of messed up. Command or on a Mac or Control on a PC, Control T will line it all up for you. It'll automatically indent all your code the correct way. Control T, spam Control T, like you wouldn't believe. Thanks, Seki. Yeah, that's exactly you're already anticipating a thought we're going to have. Yeah, Taiki has noticed something really cool. He has noticed that my house has an X and a Y parameters, and my spaceship has X and a Y parameter. And you might think, wait. Back in programming 11, when I made my whatever animation, I had an X1, an X2, an X3, an X4. Some of you had like ridiculous amount because you made such a big animation. X49, I recall seeing. It was like the name of Elon Musk's baby, you know, like that's how like the variable names are getting so huge. So, so interesting to note, these variables here, these parameters, they are local variables. They are local only to this function. So you can name them X and Y here, and they won't conflict with the parameters up here in house. So they can both be named X and Y. So you don't have to have X1, X2, X3. You can just call them X and Y. Now, if you're wondering, what if you also have a global variable called X? Let's talk about that in another class. We don't have time to get into all the possible complications here, but that is a solvable problem too. But we'll just leave it at noticing that these are not global variables. They are local variables that only exist inside of the house function. They are created when the house function starts, and they are destroyed when it ends, and you never have to worry about them conflicting with other variables of the same name. Awesome observation, Taiki. Thank you so much for bringing that up. Okay, so now I'm going to run my spaceship, and you'll notice there's a bit of a problem here. My X and Y, I'm not using it. So what do you expect to see? Like just one spaceship, right? I'll show you. Oh, I guess actually I have to say draw a spaceship. Here, let's get rid of the house. And let's call spaceship. It doesn't matter where we put it. Like, we're not using the X and Y, right? Let's actually draw two of them. Just to prove it. I like 0, 0 because it looks like an owl inside of the function there. Hoo, hoo. Okay, I'm running it, and you'll be surprised. What do we see? We see two spaceships. Oops, the fill spilled over from the last house. What the heck's going on? It's like the 0, 0, it's not working or something. But we know if I change this to like 100, 100, it shouldn't work, right? That doesn't do anything. It's still the same thing. So those numbers aren't working, but we're getting two spaceships. What's happening? Go ahead, William. Yes. William, you got it. So check it out, folks. Translates stack on top of each other. So this translate, the first time we call spaceship here, when we call spaceship 100, 100, the numbers don't matter here, by the way. Let's just leave them as 0, 0. They don't matter yet, anyways. Well, first time we call it, we translate to 200, 200. So the first spaceship is this one. It goes 200, 200. The second time we call spaceship, that is 0, 0. So we translate to 200, 200 again, which is now here. Oh, they stack on top of each other. We don't want that to happen. We want it to always kind of like, we want to translate it all over the place, but we don't want it to be always relative to the last spaceship. We want it to be fixed relative to maybe the original origin spot. So what you're going to do is you're going to add in the fanciest functions you ever did type in, you're going to start the top of spaceship with push matrix, like the Matrix movie. Did we watch that trailer last class? Right? We're in the Matrix now. We're here. We're taking the red pill. We're going into the Matrix. And then we're going to end the function with pop matrix. Again, capital M. Push matrix, pop matrix. So it turns out the word matrix isn't necessarily meaning this cool place where everyone wears fancy sunglasses and has so many guns and can kung fu fight like there's nobody's business. That's a cool version of the matrix. But more blandly, in mathematics, a matrix is a grid of numbers. And all of these transformations and rotations and all these kind of things are all done through grids of numbers. You don't really need to know that. All you need to really know is that push matrix, it starts a temporary set of transformations. And I mean that in the mathy sense, like translations, rotations, reflections, all that stuff you may have learned in math. Pop matrix, it ends and resets every transformation back to normal. So this resets transformations, such as translate and rotate, we'll see later on. So this resets transformations back to what they were. So now they'll be unique each time, and they'll be relative to the original coordinate. So if I run it this time with the push and pop matrix, I'll just see the one spaceship. They're getting drawn on top of each other. So that's good. That's what we expected. And to finish it off, how do we make this x and y mean something? What's that final step we got to do? Where do we stick that x and y? What's that, John? Oh, this is like the point of the Matrix movie where Neo's like, do you mean that when I have mastered the Matrix, I will be able to dodge bullets? And then Morpheus says, no, I'm saying that once you master the Matrix, you won't have to dodge bullets anymore. So we don't have to mess around with these arguments anymore. We don't have to dodge bullets. We can just stop them right there. We can just do everything in the translate. And we don't have to mess around with these numbers. These numbers were hard. I had to think so hard to get these numbers. It's not that hard, but hard enough at the end of the day. Now I can stick the x and y right here into the translate. And I don't have to change these numbers and be like plus half of this and minus half of that. These numbers can just stay the same. And if I run it, now I can get two spaceships. Oops. I guess I left them at 0, 0. So let's put them out there. I'll say this one's at 100, 500, and this one's at maybe 500, 100. So I'll change the arguments, which means the spaceships will be drawn at different places. Yeah, there they are. They're out there in the world. So now I just need to control x and y in the translate. And now I can draw spaceships all over the place. Woohoo! So that's the power of push and pop matrix. This pre-drawn shape can now get put all over the place. I don't have to recalculate. This doesn't have to turn into algebra. These numbers can just stay where they are. So that's pretty great. So there are two different techniques, right? The one we use for house and the one we use for spaceship. Two different techniques to accomplish similar things. And they're just different tools on your tool belt of programming. So you can choose which one you want to use depending on the situation. So if it's something that's highly formulaic anyways, you might want to use the same thing we did for house and turn it all into variables. But if it's something intricate that you want to draw and like specify with coordinates, and this looks a little hard to convert right into some kind of formula, you don't have to. You can just translate it all over the place. And push and pop matrix offers another advantage as well, by the way. There's other transformations that you can do. You can also do rotations, for example. You can also scale things and expand them and make them smaller. There's a bunch of possible things. So let's add in two more little pieces of coordinates. I'm sorry, I don't think we'll have enough time to do much fun stuff at the end. I'm stealing all your time. I'm sorry. But this is gonna be mind-blowing when you see it. It's just so nice. Let's throw in in the spaceship, let's add in a scale. And if I was just to type in scale, if I say scale 100, if I run that, you won't see a lot of differences. Oh, sorry, you will see a lot of differences. Scale 1, I guess, that means like 100%. But if I type in scale 2, it'll become twice as big. I didn't have to do anything. It just grew fatter, right? I can make it 0.5. It shrinks down. That's nice, right? That's really feels powerful now. As opposed to how we did it with the triangle with the plus and minus, that was fine, totally fine. Don't feel bad about that. That was good. But this seems a little bit more powerful because it's just one number. It does all the work for you. So I like that a lot. Also, rotate. You can rotate these. So I can say rotate. I really wish right now I could say 45. I'm sorry I can't. I would love to say 45 degrees. Unfortunately, rotate expects radians. Because it turns out, like once you get into high enough math, degrees are left behind. No one talks about degrees anymore. So processing was assuming people would use radians. I don't think that's true though. I think a lot of people that use processing aren't really into radians. We won't talk about what they are. I'll just show you how you can convert it. You can do an f of g of x kind of move. You know, like f of g of x, where you're like, like the pineapple pizza we saw earlier. You can kind of stack functions. So I can stack the radians function, which translates degrees into radians. So watch this. Rotate. Instead of 45, I'm going to say radians 45. And it's kind of an f of g of x kind of thing going on here. So radians 45 converts 45 to radians. I won't go into what those are, just another kind of degrees. And then we'll rotate to that. So basically this allows us to rotate to 45 degrees. If I run this, you'll see our spaceships are now rotated. That's pretty nice. We can do a lot of stuff with that. I can change this to whatever angle I want it to be. You can even go like 720 and it will like calculate, what it's supposed to be. So you can do whatever you like. You can put in a negative number here. Okay, so last thing we're going to do is I'm going to ask you to change this function so that in spaceship I can include an x and a y as well as a size, like a size factor. So if I say 2, it'll be double, 3 will be triple. And also an angle, like 45 degrees. This one will have same idea. Maybe I'll make this one 1. And it'll be rotated to 90 degrees. I'd love to build that into my spaceship function. Obviously, it doesn't work yet because that's broken. So I'm going to leave it to you guys to figure out how do you do that. We already know what scale and rotate works with, but somehow we got to connect these arguments to those functions. How do we do that? Take a moment to think about that. I'll drink some water while you think. I'll put the spaceship function back on. Water. One of my biggest challenges of starting back at school again is remembering to drink water. Thanks for giving it a shot, everybody. Jason, I salute your family. We have all of the windows open and aircon on, but it does struggle. By the end of the day, everything running a very popular nice. Great extra one and smart. Yeah, I was joking about that one. I sell $5. You would think people would buy in those. I suspect they probably. You never know. Maybe they will. Yeah, for sure. You got it? Awesome. We're just gonna finish it off. So basically, show the answer. We'll put variables in there and make them spin around. But that's fine. All right, everybody. Hopefully, you were able to piece together what you're doing. Again, it's all about connecting. We want to connect these numbers to our functions, and the way to do that is through parameters. That was really the theme of the show today. If this was an episode of Sesame Street, it would be brought to you by parameters and arguments. That was really like the big stars of the show. So I'm going to add in 2 more parameters, int, I don't know, S for size, and int A for angle. I don't know, I'm just making these up. And I'm going to put the size in the scale function, and I'm going to put the A in the radians function, which is in the rotate function. And so now my arguments are connected to my function. So if we run it, we get big spaceship at 45, a little spaceship at 90 degrees. Hey, it's working. And guess what? This spaceship is every much as customizable as the ellipse or the circle, right? I can stick variables inside of here. Just like we made our circle travel across the screen, now I can make my spaceship travel across the screen. I'll go ahead and do that. I'm going to make some global variables. I'll make an angle variable. Let's start it at 0. I can put angle inside of, what's the more impressive one? I guess this one's a bit bigger. Maybe I'll move it out to 200. I can stick that here. I can say angle. And then I can say angle equals angle plus like 5 or something. And I can make my spaceship turn. Unfortunately, there's no background, so it'll make like a weird like pattern, which is kind of cool, actually. I like it a lot. But I can stick in, you know, I'm not sure why there's these houses. Are they outer space houses? These are the important questions. But we stick a background in there, and now my spaceship's turning. And I can make it go across the screen. Eventually, we can make it like point towards the mouse pointer. And we're halfway to making asteroids already. So that's pretty useful, hey? I hope you found it interesting, and you can see the value in push matrix, translate, scale, rotate, all sorts of fun stuff. I have to say, you will be surprised how often we use this. When we were making platformers a few years ago, this is before COVID, some students wanted to make a Smash Bros. Like game. So, you know in Smash Bros. When the characters like approach each other, the camera zooms in, and like the world gets kind of smaller, and you can kind of focus in on the battle. But as they separate, it zooms out, and you see more of the map. We were able to do that with just the scale function. And you know how it travels along and sees where the character is moving? Like, you know, if the action is happening at the top corner of the map, like the camera zoomed in on that, that's just the translate function. That's following the center point, the midpoint between the 2 characters. And so, like, all these things are like what video games do all the time when we go and do the first-person 3D stuff. It's going to be similar, although it'll be in 3 dimensions. But we'll be doing translations and rotations, all that kind of stuff. It'll be a little bit fancier, but it's the same kind of idea. So I'm really looking forward to getting to do that, all that stuff with you guys. Now, I originally wanted to make like some function that's a face. We got 9 minutes. What do you think? Can we make a face in 9 minutes? Yeah? A simple face. It doesn't have to be beautiful. Let's do it. Let's go for it. Let's make a face. So I want you to make a brand new function, starting over from nothing. It's going to be a face. It doesn't have to be pretty, but it does need to include, here, I'll define it with you. Void face. It should have an X and a Y. And maybe, what else? Ooh, it would be nice to put in like a Boolean or something. Smiling. No, we won't do that. We'll get too crazy. But we'll add in maybe a color. Let's put in RGB as well. We'll put int. And I'll let you choose which one you want to use. Do you want to use the formula style, like our house? Or do you want to use translate, like our spaceship? Each one has its own kind of advantages, and it kind of depends on what you want to do with it. But, you know, it's the end of class. I'll just let you choose whichever you'd like to practice with, okay? So go ahead and make that face function. Call it a few times. Put some faces out there to combine with your spaceships and houses. It's the weirdest video game of all time. Well, maybe not the weirdest. There's weirder ones, to be honest. But it's a weird one. Lucas, we're just trying to sneak in one last thing. We're making a brand new function, a face.
Okay.
You have to put in X, Y, red, green, and blue. Doesn't have to be fancy or pretty. Just like from the beginning. And this time you're going to call it yourself, like in the draw function. and you're going to just choose whatever you want it to look like. Okay? Thanks, folks. I'm going to stop the video. Thanks, everyone who's watching the video. Hopefully that made sense to you. Feel free to ask questions anytime if you watch this video and you're confused. Bye.